Hello everyone. So welcome back to our YouTube channel. And today's question is delete the middle node of a linked list. So let's just take a look at the question. So we are given a head of the linked list and we have to return the middle node and return the head of the modified linked list. So the middle node will be n by 2th node from start using zero based indexing and yeah. So from the example as we can see, so this is a odd linked list and middle is 7. So after that it will be 134 and remove this 126. Yeah. So in case of even, so we have to remove the next node of the middle. Okay. So it will be 124. Yeah, got it. Okay. So let's just have a small intuition and drive our intuition from this. So we are given a linked list and we have to remove this middle, and the linked list will be 1, 2, 4, and 5. So how we can do basically, so if we just update the two next connection to 4, so and return our head, so it will be 1, 2, 4, 5 then. Okay. So and we will also need to free this node, so it will not be kept in the memory and it will not create any problem. So yeah, so we have to just remove this middle node. So what we can do, I've also created a video of finding the middle node of a linked list previously. You can watch that. We will be using the similar approach here, brute force and the tortoise and hare algorithm. Okay, so what we can do basically, first step, if we somehow find this node, somehow find this middle node, like, and we had removed this from here stating the updating the connection, then we can do this. Okay, so like the position of this node is n by 2 plus 1th. Okay, so if we can find this node and update this node next to next, like 2 next will be updated to 2 next, then it is all clear. It is done, right? Okay, so as we have done in the middle, this is n by 2th plus 1. So it will be n by 2th node. Okay, so we can just find our length and like up go to this n by 2th node and update it next to next, and we are done. Okay, yeah, so think it is clear. So we'll have a just small pseudocode for this. So we will find our length. Let's just take length 0. Okay, and temp to head, and while temp is not equal to null, we will length plus plus. Okay, and after that we will find our deletion node previous. Okay, or like anything we can name it. It will be length by 2. After that we will again initialize temp to head, and while move it to temp not equals to null, we will decrease our deletion node, and once it is 0, deletion node is equals to 0, we will go out of this loop break. Now what we'll do, basically we will update our connections. So now temp will be at n by 2th node, so temp next will be temp next to next. Also we have to like for somehow keep this previously in some node and then delete it also. Okay, then we must return our head. So it will be a small pseudocode we can follow, and the Okay, so the time complexity in this case will be big of n for finding the length plus big of n by 2 for going till that node and updating the connections, and space complexity will be big of 1 only. Yeah. So we have to optimize this solution. So to updating the time complexity. So and we will be using tortoise and hare algorithm now. Okay. So as we have seen previously also, so in tortoise and hare algorithm, we have two pointers, slow and fast. Slow moves by one step and fast moves by two steps. So let's just go over the example again. One, two, three, four, five. Okay, and keep our slow and fast here. So as we have done in the middle, finding the middle node of a linked list, we keep both the same. So small trireme will be slow here, fast at 3, slow at 3, fast at 5. Whenever fast reaches the last node or like after that, we will like get our middle node. So we have to delete this node and we have to get this one. So what we can do basically, if we like skip the step one step of slow, so we can have slow at this node, right? We can have slow at this node if we skip one step of slow. We will not skip fast because we need to find the middle, but if we skip one step of slow, we can reach the previous node, and once it is done we can update the connection. Okay, so yeah, we can do the same. So the small pseudocode will be similar to that one. So keep both first at head only, and we will update our fast only to skip one step of slow initially. Okay, skip one step of slow. Now we will do the same, both move both the pointers together until fast reaches null, and fast fast next is not null. Slow by one step and fast by two steps. Once this is we come out of this loop, so our slow will be here at 2. So now we will keep this slow in some temp temp no, not temp. Yeah, we can keep this in temp or any other name. Okay, slows next. We'll keep this 3 in some variable and update our connection. Slows next will be slow next to next. Now we have updated the connection. Now what we have to do, we have to delete that node, delete temp to free that in the space and return our head of modified linked list. So yeah, this is a small trireme and pseudocode, and the time complexity in this case will be big of n by 2, and space complexity will be big of 1. Okay, so now just move to the coding part. So as we have done the pseudocode, we will use the same. Initialize slow to head and fast to head, and move our fast and skip one step of slow. to reach the one node before middle. Okay, now what we'll do, basic step to check if fast is not equals to null, and fast is not equals to, sorry, fast next is not equals to null. If it is not, we will move fast by one step, slow by one step, and fast by two steps. After that, we will come out of the loop and reach our this position 4 and keep our middle somewhere in some temporary node. Slow next. Now we'll update the connection. Slow next. Now we will delete our temporary. Okay, and return the head of the modified linked list. So yeah, it is done. We will run our some sample test cases. It is working fine. Yeah, now just try to submit it. Okay, so we have to handle the base cases in case we are given a null linked list. So if head is already null, or if there's only one node in the linked list, as we have seen this, there is only head next equals to null. So what we'll do, we'll just return the head stating that we cannot do any operation on that. So I think it will work fine now. Take it and test it again so that we can have a confirmation. It is not working fine. Okay, so in case of one, we have to return the null only because we have to delete that. Yeah, so it is working fine now. Thanks everyone for watching. In case you do like this video, please do subscribe our channel and we will do more questions together.